Good morning, students. I am Uma Maheshwari, Head in Charge, Department of Psychology, Hindustan College of Arts and Science. Now, we will be seeing about the neural communication and how it is happening in the nervous system. We all know that nerves are the functional unit of the nervous system, which means that messages to be conveyed from the brain or to be taken to the other parts of the body through the nerve mechanism. Now, there are various processes going on inside a nervous system. The important process is the action potential. We will see about action potential in detail in this session. Nerves are the functional unit of the nervous system. The nerves compose of 4 components, that is the dendrites, which collect signals from nerval membranes. From there, it is taken to the cell body or the soma, where the processes is being done. There it is being carried through the axon and it is distributed to the next neuron through the terminal buds of the axon. So, that is how the nerves will carry signals from one membrane to the other membrane. Now, there are certain processes how this happens. The neurons transmit information through chemical messengers called as the neurotransmitters. These neurotransmitters move from the previous membrane to the particular neural membrane, the dendrites or the branched structures which collect the nerve impulses in the form of neurotransmitters, and it will be carried to the cell of the neuron. There the processes occur. The processes will accumulate, that is the cumulative effect of the inhibitory postsynaptic potential and the excitatory postsynaptic potential together. It will affect, the cumulative effect will cause the axon hillock to get stimulated. It is at this region that the axon hillock will get give the signal to the neural membrane, and the impulse has to cross through the axon and it has to reach to the next membrane. Generally, the neurons are negatively charged in the sense that the inner side of the membrane has minus 70 millivolts membrane potential between the inside of the cell and the outside of the cell. So, that is the electrical gradient. And we see that a lot of ions are present in the cell, that is positively charged sodium and potassium ions, important ions are present inside and also the outside of the cell. The concentration of sodium ions is more on the outside of the cell than on the inside of the cell, right. This creates a kind of concentration gradient. And also there lies an electrical gradient, in the sense that when there are more of sodium ions in the outside of the cell, it will have an effect on the sodium. It tends to push the sodium into the neuron, whereas there lies negative potential inside the neuron which tends to attract sodium ions from the outside of the cell. So, we see that there are 2 forces acting on the sodium ions. One is the electrical gradient and one is the chemical gradient, both tending to push the sodium ions into the cell. Whereas, the potassium ions are more concentrated inside the cell. Now, here also 2 actions are in process. The concentration gradient tends to push the potassium ions outside the cell, whereas that is ionic gradient tends to keep it inside, that is the electrical gradients. Already the negatively charged neuron tends to retain the potassium ions inside. So, it is somehow balanced. So, what happens when there is a semi-permeable membrane? This is not happening, that is most of the sodium is not getting inside. The reason is the semi-permeable membrane will selectively permit certain ions to pass through it. That is how the concentration of sodium and potassium is being maintained inside and outside of the cell. So, that is one way of maintaining the ionic gradient. Now, at resting membrane potential, it is, as I told you, it is minus 70 millivolt. This is the resting membrane potential, And when does the ions tend to move or outside the cell? When there is disturbance for this resting membrane potential. When will the disturbance occur? When a signal is coming from the previous membrane. So, when some cumulative effect of the transmission which is being passed into the cell from the previous cell, when it has an effect which is tending to increase the positivity of the cell, that is the positive ions are getting more inside the cell, then there is the neuron firing. The neuron is said to be fired when there is more of positive ions entering. Now, how will this happen? When the signal is got inside the cell, right? When it is moving through the axon region, that is where the sodium potassium channels are there on the membrane which get the signal to open, right? So, when it is slowly opening and closing, 3 sodium ions will be let outside, leaving inside 2 potassium ions. In this way, slowly for every opening and closing of this sodium potassium pump action, what happens is, for every 3 sodium ions put outside of the cell, 2 potassium ions tend to come inside of the cell. The negativity of the cell is increasing. When this is going on increasing, the sodium potassium channel is in action, and when an impulse comes inside, when it will tend to increase the positivity of the cell, so that the action potential is starting. When the action potential will start? When there is signal from outside. If the signal is weak enough, the action potential will not be taken up. When the signal is very strong, like a pain or something like that, when the signal is very strong, the action potential will get triggered and it will reach its maximum, right? After then, when it reaches a particular point, that is a peak point, then it tends to return down, right? When it tends to return, that is the sodium channels from minus 70 millivolt, it will move up to plus 50 millivolt. Until then, this action potential will shoot up. Once the gradient is changing, what happens is the sodium potassium pump will close, the sodium channels will close, and the sodium potassium pump will stop its action. It tends to bring down the negativity of the cell. More of potassium which is present inside tend to go outside. So, we saw that potassium channels are positively charged ions. Now, when these positively charged ions are released outside, what happens is negativity of the cell increases, which is called as hyperpolarization. Now, when this hyperpolarization happens, it will happen to a stretch that it is crossing below 0, that is it is crossing below 0 or even below the resting potential, and it will have a refractory phase. Slowly what happens, sodium potassium channel will open and the potassium will tend to regain its position. That is, the sodium potassium channel comes to action where the potassium level is maintained inside and outside, and the sodium channels are open now. This will bring it back to the resting potential, and this refractory phase is very important because this is what keeps the signal from moving backwards. It will try to move only in one direction. It won't let the signal to pass in the opposite direction. So, that is how the direction of this is maintained. So, we saw that the resting membrane potential is maintained because of the concentration gradient between the outside and inside of the cell. We saw how the sodium potassium pump functions, and the sodium potassium pump functioning needs some energy for it because it is fighting against the gradation already present in the inside of the cell. So, it is an active mechanism which includes which needs the energy released by the breaking down of the ATP molecules into ADP molecules. And this is a graphical representation of the action potential. We saw that the resting membrane potential was the minus 70 millivolt. From there it reaches a kind of until the sodium potassium pump will be in force until it reaches a threshold of minus 50 millivolts. It won't get affected, and after then suddenly it shoots up, which is called as the action potential, and from there sodium channels close and the potassium channels open, releasing the potassium ions, brings down the number of positive ions inside the cell, or we can say the negative charges increased inside the cell, which is called hyperpolarization, and after a very meager refractive phase we then come back to the resting membrane potential. And after then we have seen that how this action potential is created, and now we are going to see how it is being propagated, right. Now when the potassium ions are more in number, as I told you, it is giving a kind of positivity inside the cell. When the sodium potassium channel functioning, sodium ions which are also positively charged will also contribute to the positivity of the cell, which means that the neuron is fired. This neuron firing will tend to move from one location to the other location, before which the membrane will, the signal will propel this movement. So gradually the electrical gradient between the inside and outside of the cell will facilitate the movement of the action potential. So how does this travel through the axon? The axon is a structure which is ensheathed by a myelin sheath, right. This myelin sheath gives a kind of insulation mechanism, and it has here and there certain node-like structures. This myelin sheath is not a continuous covering, it has nodes here and there where there are no myelin, and this is the area where action potential happens. Within the myelin there are no sodium channels, so action potential cannot happen. So when the action potentials are happening at the nodes only, we see that the action potential is traveling fast through the axon, because the axon is an elongated structure, it has to travel very fast. So this mechanism of jumping of action potential from node to node on the axon is called as saltatory conduction, because it is jumping from one node to the other node and it is moving towards the terminal bud region. So this myelin sheath facilitates a speedy movement of the message or the signal. So we have seen that saltatory conduction happens only at the nodal regions. Action potential happens in the nodal region, and that is what contributes to the saltatory conduction, which enhances the speed of the message conduction. So we after reaching the end of the axon, actually it has, as I told you, when it reaches the terminal bed region, there the message is communicated to the next cell in the form of chemical messengers called as the neurotransmitters, and the neurotransmitters are specialized chemicals, and these specialized chemicals can be either positively charged or negatively charged, right. When these chemicals are passed on to the next membrane, which is called as now this is called as a presynaptic nuclear membrane. The next membrane will be called as the postsynaptic membrane, and when it is moving from this membrane to the other membrane, right, there are certain receptors which are specific to specific neurotransmitters. So for example, when certain neurotransmitters will have an excitating effect and certain neurotransmitters may have inhibitory effect, which means that certain transmitters will have more of positively charged ions, that is sodium ions, which will induce or enhance the conduction of the transmission of the message through the next cell membrane, or otherwise we can say certain neurotransmitters like the GABA or gamma aminobutyric acid. So this is an inhibitory neurotransmitter which induces negativity to the cell, which thereby slows down the transmission of, or otherwise it will the impulse may not be so severe to be conducted. So that is how the transmission is affected. So only the excitatory postsynaptic potential will create the action potential, whereas the inhibitory postsynaptic potential may not induce the action potential, whereas it will facilitate the hyperpolarization. So I think you are clear about transmission of messages through the neurons. Hope you understand. See you. All the best.